Welcome to the Aiken Center, a newly renovated green building at the University of Vermont. Faculty, staff, and students in the Rubenstein School realized that we need to change our building. We needed to represent more of what we do and how we feel about the world. Natural light and natural ventilation actually provide a healthier, more environmentally friendly atmosphere for people to learn and work in. We have triple glazed windows that are very efficient at reducing heat transfer. We have a highly efficient HVAC system, which is heating and cooling the building. It didn't used to be cooled, but yet we're using about 50 to 60% less energy to do it. All the wood that you'll see in this building was cut, processed in Vermont. In fact, from our research forest that is FSC certified, which is Forest Stewardship Council certified, which means it's sustainably harvested. It's done in such a way that maintains the forest ecosystem without doing any damage to the other services that the ecosystem provides. Students went out with faculty, selected the trees, helped cut them down, helped bring them through the milling process, all the way to the point where they helped figure out where the wood was going to go. Students still learn because we have 9 species of wood represented in the building, so they'll learn what wood properties are best, how they look, and they continue to learn by working at our research forest, which demonstrates good sustainable harvesting techniques. It's actually 8 green roofs that are separately monitored so that we can change the plants, change the soil, and statistically look at it and see what plants or soils are best at treating stormwater and minimizing peak flows so we have reduced erosion. We had 40 or 50 students helping us install the green roof last fall. And we feel that this is an important contribution that the university and the school and us as researchers and students can contribute to Vermont, basically, or to the lake. We're developing systems that can reduce contaminants and water flow that go into Lake Champlain. We'll learn from this well-designed experiment what works best, so that we can then make suggestions for other people and do some calculations, like if half the buildings in Burlington had green roofs, how much runoff, how much contaminants will we save going into Lake Champlain? We have to be able to measure the green roof, the water quantity and the water quality coming off of each one of those 8 watersheds. And we actually do that with a tipping bucket system, which basically means all the water from a given watershed comes through here, drains into this bucket. The bucket tips each time it fills and sends a signal to a computer, recorded, and we can actually collect water out of these tubes at any time during the process and show the differences between watersheds in water quality and water quantity. So this is the fun part. Most fun part, I think, is that it ain't over. We're continuing now. We have more students all the time. We have interns that work with us throughout the year. We have classes of 30, 40 students continuing to improve the building, but also using the data that we collect so that we could advise other people that are doing the same thing in their buildings. This is rare that a building would have so many sensors and so much data and allow us to learn from the building from now on. We knew this wasn't something that was just cool to do, it was necessary. It had to be done this way. And we all have to strive towards that in the future if we're going to provide a better, cleaner globe for us to live on.
The American robin has kind of a nice warbly song. One of the reasons why I first started picking up bird calls is I realized that there was a bird out there that was making a noise and I just couldn't see it. I was pretty sure I knew what species it was, but it was just hidden in the forest. So I said, well, what the heck, I'll try an imitation. And the first time it worked, the bird came closer. I was like, wow. I found that getting students outside and getting them excited about the natural world and wildlife is really easy when they can have those personal connections. So seeing a species, seeing a bird, seeing a mammal up close really gets students excited about the natural world. And I think they develop this connection in terms of how can I save this? How can I make this place better?
Every spring we put out fish traps to catch small newly hatched trout because we're trying to assess where the trout are and how many are hatching. And it's been a common observation for years that in those traps we will get sculpin. And some of those sculpin are substantially bigger than the whole of the trap. So the observation that intrigued me was this ability of sculpin to get into a space apparently smaller than its head. And what I needed was a student to work with who could have the knack of taking care of fish in the laboratory and watching behavior carefully. So it's what we call finding a student with a slimy thumb. So we began with the simple observation. That's how all science begins. What Harrison was able to do in the lab is turn that simple observation into a quantitative study where he was able to look at many sculpins in his tunnel that he developed and get an idea of how many of them ended up going into spaces smaller than their head. So his discovery was this ability of sculpins to compress their skull to get into a smaller space. And to the best of our knowledge, looking at the literature, nobody's actually looked at that ability for a fish to malform its skull. And then the eureka moment in some ways was Harrison's ability to find a method to actually quantify it, to put it into numbers, so that he was able at the end of the day to come back to me and say, yeah, yep, you're right. They are getting into funnels smaller than their head. It's like, got it. Right, we can put numbers on that. And that's exciting.
I'm Kirsten Collins, captain of the research vessel Melisira here at University of Vermont. Melisira is our research vessel here at UVM. We moor it up right next to the Rubenstein lab. So we're right downtown Burlington, right here. And so we go out for a variety of reasons. We do all types of research on Lake Champlain. So that involves fisheries research, fisheries collection, underwater autonomous vehicle testing, underwater robots. We have divers that go off. We test the water quality of the lake. Anything we can do to research what's going on in Lake Champlain, we can do it from the Melisira. I'm originally from Massachusetts, grew up on the South Shore and down the Cape. So at 5, my dad just kind of gave me the helm and said, you know, take the small dinghy. Dinghy turned into lobster boats, sailboats. Eventually went to Massachusetts Maritime Academy, graduated in 2009, and have been working on boats and ships ever since. Everybody loves what they do here. Everyone's enthusiastic, the energy is there. We're all excited to be a part of this team. We are a team, and that's the most important thing.
I'm Carol Adair. I'm a professor in the Rubenstein School at the University of Vermont. One of the things that we think is really important in the Rubenstein Environmental Science program is experiential learning. Getting you hands-on experience, knowledge, and confidence to do the work that you want to do, whether that's conservation work or scientific research. There are a lot of opportunities to get out on the lake, maybe on the Melisira. We also have research forests if forestry is more of your calling. So we have just a wealth of opportunities from sort of the mountaintops all the way down to the lake. The students coming into Rubenstein are not only smart but motivated to create change, and that's what we want to foster. You really can make a difference in the things that you do here. Policymakers are very interested in the science that's going on, so your science can make a big difference in environmental policy. So environmental scientists that graduate from our program also tend to be very successful. So within about 6 months of graduating, 93% of our students are either employed or have moved on to higher education. Why environmental science? Because we have never needed environmental scientists more. We need good scientists, motivated scientists, to not only understand the problem, but want to work towards creating solutions with policymakers and other folks who maybe don't have the science background. So we need you to have that science background to make the whole thing work.
Henry, thank you so much for taking some time to talk to me, allowing me to go birding with you and your mentees from Flynn Elementary. Tell me a little bit about this course that you're taking now that you have allowed me to participate in, and I understand this isn't your first time.
Definitely. So Birding for Change, taught by Trish O'Kane, is my favorite course I've ever taken at UVM, and it's just a way to get outside and engage kids outside. It's not about really necessarily like teaching them things like, oh, like, what is this and what does it do? It's just an opportunity and an experience for them to look around them and be able to make those observations for themselves, and be able to see something and ask, what is that? Why is that the way that it is? But I took this class kind of on a whim in the spring of my sophomore year. So incorporating birds and nature outside with kids, I thought that could be something that would be fun. And it became my whole world.
So tell me a little bit about that whole service learning component and how you think it helps you as a college student from an academic perspective.
There's nothing quite like actually being able to go outside and be able to do this every single week. Like, this is my classroom, like this is what I want it to be like going forward, not just in this class. This semester, me and a couple of my friends have basically worked really, really hard to set up a chapter, and UVM now has an Audubon chapter. It's one of the first chapters out of college around the nation. And we're really passionate about getting kids outside, getting kids birding, of course, but also not only having that opportunity to recreate and enjoy, but to really learn and get an educational experience out of that as well.
And that's what it's all about. And so you know our focus is student success for our college students, but you're also committed to student success at the elementary and middle school level as well. And do you know what the next step is after the...
I have an idea. I really do want to pursue environmental education at the grad level. That's kind of my plan. I don't know quite where that's going to take me, but so long as it takes me outside and I get to still be able to interact with kids, I think that's going to be my number one thing.
Well, we're so glad that you made the choice to come to UVM, and I know you're giving back already in so many ways, and I'm going to keep my eye out on you.
Thank you.
So how did you get here? What made you decide that this is what you wanted to do?
Well, an obsession with fishing. I'll just start there.
Okay, I can understand that.
Yeah, it starts there and it doesn't end. Honestly, I just want to be around fish all the time.
So I'll tell you my very first experience fishing, I was 7 years old. I had 4 brothers, and my dad took us fishing, and I caught 7 fish. My brothers didn't catch any, and I loved it, but you know what, they never asked me to go fishing again. So tell me a little bit about what you're doing this summer and the research that you're involved in.
Yeah, so I'm actually part of 2 different projects. One's with Rosalie, she's a postdoc. She's trying to build a food web model for Lake Champlain because one has not been developed yet. I work with a program called ART, it's a statistics program. Basically every week I'm doing a different project, so whether it's rainbow smelt, zooplankton, sculpin work, it changes all the time. I'm basically the one who creates these little puzzle pieces. She's the one I feel like who puts them together. The second one, I'm a field technician for the boat, and they're targeting lake trout. They're hoping to see wild lake trout recruit. You get hands-on work, you get a little bit of work behind the scenes. Some of the more difficult stuff, such as programming for me. You really get a lot of good experiences and connections with people here.
Right, that's great.
All my experience with the equipment we're using, for example, fyke nets, gill nets, midwater trawls, benthic trawls, it's all super important for technician positions.
I think what's really important too for students is to understand from an academic perspective, you are doing programming, computer science kinds of things and math things, but then you're on the lake and working with fish so people can actually see the pathways to achieve your ultimate goals.